All right, welcome to the next video on exponential functions. We're covering all the topics in this section, and today we're looking specifically at the graphs of exponential functions. So this is going to be split into two parts. This is part one for the graphs of exponential functions. All right, so as you can see, there's a lot of standards attached to this specific skill, but our objective today is to focus on graphing exponential functions and describing the end behavior of the function. So what you're going to be able to do, just focus on this one part over here. Understand the connection between the y-intercept, the rate of growth or decay, or what we might call the common factor or ratio, and what we call the end behavior of the graph, what's happening at the extreme ends of the graph for exponential functions. All right, so let's do a quick review of what we learned in the previous video about exponential functions. So let's take a look at a normal exponential function written in the form f of x equals a times b to the x. So this is the same thing that we covered last video that said y equals a times b to the x power. Okay. So just a quick review question. Which key feature of the exponential function does the a term represent? Right, the a term in a times b to the x represents the y-intercept of the graph. All right, so in the graph, so if we look at this particular graph here, the y-intercept is where the line crosses the y-axis, and that's here where a is equal to 1. Okay. Now, which key feature of the exponential function does the b term represent? So b to the x, the b represents what? Right, so hopefully you remember that the b represents the common ratio or the common factor. How is the y value increasing or decreasing every time we move over 1 on x? All right, and if you look closely at this graph, it looks like we've got a little bit over, every time we move over 1 on the x-axis, a went from 1 to a little bit, right, a little bit less than 3. And then if we took that again and multiplied it by that common factor again, where does that end up? Up here at, so you can see we're multiplying each term by the common factor in the graph. All right, so what we're going to look at today is we're just going to practice graphing a whole bunch of different exponential equations and understanding what's happening each time we do that. All right, so let's take a look at this first one here. We're starting with the graph y equals 2 to the power of x. So in order to sketch a graph of this equation, we need to take this equation here, y equals 2 to the x, and we need to write it in y equals a times b to the x power. So I have b to the x, right? I have y equals 2 to the x power. Well, what is being multiplied by 2 to the x power? Since there's nothing there, and we've got it, if you look down here at this study edge tip that we've got down here, we can always write an exponential function such as, if it's like this, g of x is equal to 3 to the x, in the form g of x equals a times b to the x by writing the understood 1 for the a term. So if it's just y equals something to the power of x, just assume that there's an a value of 1 that's being multiplied. So our equation here is y equals 1 times 2 to the x power. Okay, so that's this equation written with both an a and a b term. So a in this graph is 1 and b is 2. So let me go over to my graph here. All right, since a is 1, that means my graph crosses the y-axis where y is 1. So I'm going to go to where y is 1, and I'm going to put a point there. So that's my y-intercept because a is 1. Now, how can I figure out the next term in my pattern? Well, if we make a quick chart here, x and y, right? X is 0, y is a, or y in this case then is 1. So if I move up 1 for x, what is the pattern? How am I getting to my next y value? Well, that's where the b value comes in. Since b is 2, I'm taking 1 and I'm multiplying by 2. So 1 times 2 is 2. So my next point is over where x is 1, y is now 2. If I want to go again, x is 2, so I multiply by 2 again. So 2 times 2 is 4. So I go over to 2 and then up to 4. All right, what if I go over again? I'm going to take 4 now and multiply by 2, so I get 8. So for 3, x is up at 8. Okay? And you can kind of see how this graph is curving up. Well, what if we wanted to go the other way? What if we started where x is 0? What if we went the other way? Well, let's think. What's the pattern? Right, if x is, let's put 0 down here, and y is 1. All right, so the one before it, x would be negative 1. Right? Well, my pattern is still going to be multiplying by 2 to go one term higher. So whatever the term was before 1, I took it and I multiplied by 2, not 1/2. Sorry. Let me take that away. All right, so I multiplied by 2 and I ended up at 1. Well, I can think what times 2 makes 1? Or I can go the other way. 1 divided by 2 would give me 1/2. So that means going the other way, x is negative 1, y is going to be 1/2. Right? What if I kept going backwards? Right? Well, what times 2 is 1/2? Right? Well, that would be 1/4. Okay? So negative 2 would be down at 1/4. Okay, so what's happening on this side of the graph is that the line is getting closer and closer, smaller and smaller on that graph. Over to the right, it's going up very, very quickly. All right, so this is the graph of y equals 2 to the x power. The y-intercept is 1, so a is 1, and the common ratio is b. We're increasing by twice as much every time. So it says, is the graph increasing or decreasing? And what that means is as we look from left to right on the graph, okay, as we look at the graph from left to right, what's happening with the graph that we sketched? Okay. All of these points, as we move from left to right, they're getting bigger and bigger and bigger and bigger and bigger and bigger. Right, so is the graph increasing or decreasing? In this particular case, this graph is increasing as we go from left to right. It's getting the y values, the graph is getting larger. So now we want to describe what's called the end behavior of a graph. And what the end behavior means is it's at the extreme ends of the graph. So if I were to extend the graph out this way or this way forever, okay, eventually we would reach what's called negative infinity, right? And that's the symbol, little sideways 8 is a symbol for infinity. Well, this way I could go to negative infinity, and to the right I could go to positive infinity. Okay, so what happens if I extended the graph all the way out to either side to infinity? Well, as x increases, so as x moves towards positive infinity, as x keeps getting larger and larger, what's happening to the y value? Right? Well, in this graph, the y value is also increasing, right? The bigger that x gets, the bigger that y gets. So as x increases, y also increases. Okay? And if you look at this graph, as y is increasing, is there anything to stop y from continuing to increase? And in this case, there isn't. Okay? As soon as x keeps getting bigger and bigger and bigger, all right, if my exponent here keeps 2 to the x, if x keeps getting bigger, bigger, and bigger, y is going to keep getting bigger and bigger and bigger. So as x increases out towards positive infinity, y is also going to increase towards positive infinity. Okay, so y increases towards positive infinity. But what happens if we go the other direction? Right? As x keeps getting smaller and smaller and smaller. Well, for this, you might think that y would also keep getting smaller and smaller forever. Right? And it would. Y would keep getting smaller and smaller, but it has a limit in this case. Right? And that's because b is positive 2. So let's take a look at b, and let's pick a number for x. In this case, we still have negative 10 on the graph, right? So let's say x is negative 10. How would we write that as in our equation? Well, y would be equal to 2 to the negative 10th power. Well, what do we know about exponents? Negative exponents can be written as positive exponents if I flip them and put them in the denominator of a fraction, 1 over 2 to the 10th power. Okay? And 1 over 2 to the 10th power is still going to be a positive number, right? It's still above 0. What if I were to make x equal to negative 20? If y is equal to 2 to the negative 20th, that's still 1 over 2 to the 20th power. So hopefully what you're noticing is that as x is decreasing, so as x is getting smaller and smaller and smaller, y is also decreasing. Okay, so y also decreases, but it has a limit. Because b is a positive number, all right, y will never be less than 0. Okay, so y is decreasing, and it'll keep getting a smaller and smaller fraction as it'll get closer and closer to 0, but it will never pass 0. It'll never be equal to 0, and it will never pass 0. Right? Because you can think about it as we were taking this column here and making x smaller and smaller, we're just dividing by 2 every time, right? Well, we can always divide something in half and keep getting a smaller and smaller fraction. That's really what's happening here in the graph. You could extend this graph all the way out for x, out this way. And if you were to zoom in, you would see that it's still not at 0. It just keeps dividing by 2 and getting smaller and smaller and smaller. So for this graph, the end behavior, as x gets bigger and bigger, y is also getting bigger and bigger to an unlimited number. But as x decreases, y is getting smaller and smaller, and it's actually approaching 0. All right, so now let's take a look at a second one here. We've got y equals 1/2 to the x power. All right, so again, we want to write this so it's y equals a times b to the x. So we've got our b to the x term. That's 1/2 to the x power. And again, just like before, since there's no number here, we can assume that a is 1. So we could say this is y is equal to 1 times 1/2 b 1/2 to the x power. Got ahead of myself. So a in this case is 1, and b, our common factor, is 1/2. Right? So let's go over and sketch the graph here. Right? So our y-intercept is 1. Right? So I'm going to go to where y is 1, and that is my starting point. Okay. And now let's make a table for x and y so that we can see what is happening with the graph. So let's start where x is. I'm going to put 0 here in the middle this time because I want to know what's happening on the other side, -1, -2, -3, and what's happening with 1, 2, and 3. All right. So where an x is 0, we know the y-intercept is 1. So x is 0, y is 1. So now what's happening as I move down or I move up on my y-axis? Well, I'm multiplying it by the common factor, which is 1/2. So I'm taking 1 and I'm multiplying by 1/2. So 1 times 1/2 is 1/2. So when I move over 1 on x, my y value now is 1/2. Right, if I go down again, I'm going to multiply by 1/2. So 1/2 times 1/2 is 1/4. So for 2, it's now 1/4. I move over again, I multiply by 1/2 again. So 1/4 times 1/2 is 1/8. So for 3, it's down at 1/8. So what's happening on this side of the graph is that the numbers are getting smaller and smaller as we move along, right? The bigger we make x, the smaller the number, the fraction gets. So what would happen if we went the other way? All right, what number before where the y-intercept, what number times 1/2 is 1, or what is half of what number would make 1? Well, half of 2, or 2 times 1/2 would give me 1, which means at -1, x was up at, or y was 2. And I can follow this pattern again. So before, what was the number before if I multiplied by 1/2 and got 2? Well, the number before it must have been 4. So -2 is up at 4. And the one before that must have been 8, because 8 times 1/2 is 4. So -3 is up at 8. So this side of the graph is where the graph is going up. So if you look at these two graphs, the first one over here in purple and this green one, they look kind of similar, right? They're just kind of going in opposite directions. So what's happening again if we want to decide if the graph is increasing or decreasing, we look at it from left to right. So what's happening as we move from left to right on the graph? The graph is heading down. So this graph is decreasing. And what's happening as we move x further and further out, again, towards positive infinity, as we move further and further out on x, this graph keeps getting smaller and smaller and smaller, right? It keeps dividing, or multiplying, sorry, by 1/2 every time. We could continue out forever multiplying by 1/2, multiplying by 1/2, multiplying by 1/2. So as x is getting bigger, as x is increasing, y is decreasing. And so y is decreasing. And what is y approaching? Y is decreasing and getting closer and closer to 0. Okay. We keep making smaller and smaller fractions when we multiply by 1/2. What if we head the other direction? If we're heading towards if x is decreasing, which means x is heading to the left towards -infinity. Okay. As x gets smaller and smaller and smaller, what's happening with y? Y is actually going up, right? Y is, you see the arrow is y is increasing as x is getting smaller. So y is increasing towards positive infinity. So there's no limit to how big y could get if we move x towards a smaller and smaller number. All right, so 2 more to do. We've got the first one here, we've got y is equal to -2 to the x power. So again, we want to write this equation so that it's y equals a times b to the x. Right. And again, what we said before still holds true. Since this is -2 to the x power, that's not the same thing as saying -2 to the power of x. Okay? Without those parentheses, what this is saying is that it's negative, or the negative of 2 to the x power. All right? So if I want to write this in y equals a times b to the x, notice this would be like -1 here. So my equation is actually y equals -1 times 2 to the x power. All right, so here I see that in my a place for my equation, a is equal to -1 and b is equal to 2. So b is my common factor. All right, so to sketch this graph, we're going to go to where a is -1. So that's down here. That's my y-intercept at -1. And let's do what we did on the last two graphs. Let's take this table here, x and y, so I can see what's happening on my graph. All right, and again, I'm going to put x in the middle. So 0 is at -1. All right, as x is getting bigger, 1, 2, 3, my pattern is that I'm multiplying by that common factor of 2. So I'm taking -1 and I multiply by 2. And -1 times 2 is -2. So if I move over where x is 1, y is now -2. To get to the next one, I multiply by 2 again, so that's going to be -4. So 2 is at -4. And then the next term, I multiply by 2 again. So -4 times 2 is -8. So 3 is over at -8. And you kind of see what's happening with this graph is that it's curving down. What if I want to go the other direction? What was the number before this if I multiplied by 2 to get -1? Well, in order to multiply by 2 and end up at -1, I must have had -1/2. -1/2 times 2 is -1. So -1 is at -1/2. And the one before that then would be -1/4. And the one before that would be -1/8. So what's happening on this side is that the fractions are getting smaller and smaller and smaller. So my graph is going to look something like this. All right, so again, let's take a look at what the graph is doing at the extreme end. So again, we want to determine if it's increasing or decreasing. We look at the graph from left to right. All right, so what's happening with the graph as we move from left to right? Well, it's decreasing. It's going down, and then it turns and it starts going down really quickly. So the graph is decreasing as we move from left to right. Now, what about the end behavior? As x is increasing, so as x heads towards, just like all these other ones we've done, as x heads towards positive infinity. So the bigger that x gets, what's happening with the y terms? Well, the y's are decreasing. So y is decreasing as x is getting bigger. And is there any limit to how negative it's moving, how far down it's going? No, it's actually decreasing, and it could go all the way towards -infinity. And so as x increases, as x gets bigger, y gets more negative, so it's decreasing towards a -infinity. And what's happening with y as we head the other direction, as x decreases? So as x becomes more and more negative, y is technically, because these are negatives, remember, it's getting closer and closer to 0, so y is technically increasing. It's moving up. And it's heading towards 0. And just like before, because A in this case, A is a -1, right? Since A is a negative number, whatever we do with B, we're going to make it the opposite. So by making this a negative number, it's kind of flipped our graph upside down. And so now y is increasing towards 0. But because we're multiplying whatever we get with B by -1, y is never going to be above 0. All right, and now we got one more to look at here. So this is y equals -1/2 to the x power. So again, I want to write this in y equals a times b to the x. And our b to the x part of this equation is 1/2 to the power of x. And what is it being multiplied by? Since there's a negative sign out front, it's being multiplied by -1. So it's -1 times 1/2 to the power of x. So for this one, a is -1 and b is 1/2. Right, so when I go to start my sketch of my graph here, we're going to put our y-intercept down at -1. And now we're going to use a table to help us figure out some of these points. So again, let's put 0 in the middle. So 0 is at -1. Okay. And what happens as I go 1, x is 1, 2, and 3? Well, I'm going to use my common factor here of 1/2. So I go from -1 and I multiply times 1/2. So -1 times 1/2 is -1/2. So if x is 1, y is at -1/2. To get my next one, I multiply by 1/2 again. So it's -1/2 times 1/2 is -1/4. Okay, so 2 is at -1/4. To get my third one, I would multiply by 1/2 again. So -1/4 times 1/2 is -1/8. So that's getting really, really small there. Okay. So my graph here is curving towards this way. What if I go back the other way? -1, -2, and -3. What number did I have before? If I multiplied by 1/2 and I got -1, well, I must have started at -2, because -2 times 1/2 would be -1. So I put a point here at -2. Right? And the one before that would have to have been -4. And the one before that would have to be -8. So I'm just filling in this pattern so that no matter where I started here, as long as I multiply by 1/2, I get the next number in the sequence. So the graph altogether looks like this. Right. And now the last thing, let's check the behavior of the graph. So as we go from left to right here, the graph is starting low and it's moving up. So it's increasing as we go from left to right. And so as we go from left to right, the graph is going up, it's moving up. What's happening as we move further and further to the right on x towards positive infinity? Y is, well, let's look here, -1, -1/2, -1/4, -1/8. It's getting closer and closer to 0. So y is increasing and approaching 0. As we head the other direction, as we head towards -infinity for x, y is decreasing. It's getting more negative. So y is decreasing as it approaches -infinity. Okay. So what we've done is we've taken a look at 4 different graphs of 4 different exponential functions and analyzed what's happening as we move along the graph for these exponential functions. So now what we want to do is kind of summarize everything that we've looked at in these 4 graphs that we've done. All right, and let's summarize this and create a table. So we've got 4 situations. We have a y-intercept of either positive or negative numbers. So remember, let's take our equation here. Y equals a times b to the x. So if a is positive, let's say a is 1. A is +1. So we're doing this first row here. And so I'll call this the first one. So a is 1 because it's positive. The common ratio r, in this case we're going to say r is the same thing as b. So r is the same thing as b. Saying b is a number more than 1. All right, so for this one, a is 1 and b from our example we'll say is 2. All right, so that would give us the equation y equals 1 times 2 to the x power. All right, and this was the first graph that we did, y equals 2 to the x. Well, what was happening with the graph? The graph itself was increasing. As we moved from left to right, the graph was getting bigger. It was moving up. Right? What was happening as we moved along the x-axis? Well, the whole graph was increasing, so as x was getting bigger, the y value was also increasing towards positive infinity. Right? So that means y was just increasing also. What was happening as x was getting smaller or x was getting negative? Y was approaching 0. Okay, it was getting smaller and smaller, closer and closer to the x-axis, or getting closer and closer to 0. All right, so that was the first graph. The second graph, a was still a positive number, so a was still 1, but now b, or my common ratio, is between 0 and 1. So what does that mean? The number between 0 and 1 was like having a b value of 1/2. As 1/2 is between 0 and 1, or a common ratio in this case of a fraction. So that was the equation. That was y is equal to 1 times 1/2 to the x power. All right, so if you flip back, you can see that for that graph was decreasing as we moved from left to right. And the end behavior, or at the extremes, as x got bigger and bigger and bigger, as x increased, y approached 0. Y was actually getting smaller. As x decreased, as x became more negative, y got bigger and was headed up towards infinity. Okay? There was no limit to how big y could get in that graph. Let's take a look at the third possibility. A is a negative number, so that's saying where a was, in this case, -1. And b, my common ratio, is between 0 and 1, so b is going to be 1/2. So that was the graph that said y equals -1/2 to the x power. And what was that graph behaving like? Right? That was the fourth one that we did. So y is -1/2 to the x power. So that graph was increasing. And it was a graph, overall that graph was increasing. But as x got bigger and bigger, y approached 0. Y got closer to 0. As x became more negative, y also became more negative, and it headed towards negative infinity. So as x decreased, y also decreased. All right, and then we've got our last one. A is a negative number, -1, and b, or the common ratio, is more than 1, so b is 2. So that was our graph that said y is equal to -2 to the x power. And what was that graph behaving like? Well, overall, that graph was decreasing. As x got bigger, y got smaller and headed towards negative infinity. And as x decreased, as x got smaller, y actually increased and headed towards 0. So this is a way that you can kind of summarize everything that we know about exponential functions so far. Right? If a is a positive number, okay, if a is a positive number, we have two possibilities. Either the graph is increasing, which means that as x gets bigger, y gets bigger. As x gets smaller, y gets smaller and heads towards 0. Or if a is a positive number and b is a fraction, the graph is decreasing because y is getting closer to 0 as x gets bigger, And as x decreases, y gets bigger and heads towards infinity. So that's our first possibility. The other possibility is a is a negative number. So if a is a negative number and the ratio is a fraction, that's an increasing graph, which means y is getting closer to 0 as x increases, and as x decreases, y is going smaller and smaller towards negative infinity. If a is a negative number and or b is a number more than 1, okay, that graph is decreasing, which means y heads towards negative infinity as x gets bigger, and y approaches 0 as x decreases. All right, so this is just a chart that summarizes everything that we did in this video by graphing these exponential functions. And down here, this tip is important. If you ever get confused about what's going on with a graph or with an equation, sketch the graph and see what's happening. All right, write the equation out, a times b to the x, identify the y-intercept and the common ratio, and then plot some points on a graph to see what's happening and explain what's happening with the end behavior of the graph. So if you're not sure, you don't have to memorize this chart, but this is a handy chart to kind of keep things straight so you can identify what a graph is going to do based on the y-intercept and the common ratio. All right, but if you're ever confused or you're not sure, just sketch the graph yourself. All right, by plotting the y-intercept and the ratio and seeing what the behavior is of the graph as it approaches extreme ends on either side.